Okay, we have 11 places where we can put these 11 letters. That's 5, 6, 7, 8, 9, 10, 11. And we have, let's just arbitrarily start with the M. If we have 11 places and we wanted to choose one of those places to put the M, then there are 11 choose one places, ways that we can put the M in. And let's just arbitrarily pick a spot there. And now let's work on the I's. Well, we've used up one of the positions, so we have 10 positions left, and there are 4 I's. So there are 10 choose 4 ways that we can place the I's in the positions. That's 1, 2, and again, I'm just arbitrarily choosing 4 spots. And now let's work on the S's. Well, we have 1, 2, 3, 4, 5, 6 positions left. We have 4 S's, so it's 6 choose 4 ways that we can insert the S's in here. 1, 2, 3, 4. And of course we have 2 positions left, and there are 2 P's, so it's 2 choose 2, which is of course just one way of putting in the remaining P's. Now the multiplication principle tells us to multiply these numbers together to count the number of ways that we could permute the letters in Mississippi. Now let's work this out. 11 choose 1 is 11 factorial divided by 1 factorial 10 factorial. 10 choose 4 is 10 factorial over 4 factorial 6 factorial. 6 choose 4 is 6 factorial 4 factorial 2 factorial. And 2 choose 2 is 2 factorial 2 factorial 0 factorial. Now let's multiply those together. And what happens? Well, the 10 factorial in the denominator cancels the 10 factorial in the numerator. The 6 factorial cancels the 6 factorial. And this 2 factorial cancels this 2 factorial. And we are left with 11 factorial divided by 1 factorial, 4 factorial, 4 factorial, 2 factorial. Okay, now you might be thinking, well, would we get a different answer if we had done it in a different order rather than choosing M, I, S, and P first? Well, let's do it differently. Let's do I, P, M, and S in the 11 positions. So we have 11 positions, and we have 4 I's, so there are 11 choose 4 ways of putting in the I's, times P. There are now 7 positions left. There are 2 P's, so it's 7 choose 2 ways of putting in the P's into those 7 positions, times now the M. We have 5 positions left, and there's only 1 M, so it's 5 choose 1 for the M. And then there are 4 positions left, and there are 4 S's, so it's again 4 choose 4 or 1. Now let's multiply those out. 11 choose 4 is 11 factorial, 4 factorial, 7 factorial. 7 choose 2 is 7 factorial divided by 2 factorial, 5 factorial. 5 choose 1 is 5 factorial, 1 factorial, 4 factorial. And 4 choose 4 is 4 factorial, 0 factorial, 4 factorial. We're going to multiply those together, and what do we get? Well, the 7 factorial cancels that 7 factorial. The 5 factorial cancels the 5 factorial. And the 4 factorial cancels that 4 factorial. And what are we left with? Well, luckily, we get 11 factorial divided by 4 factorial, 2 factorial, 1 factorial, 4 factorial. Because the 0 factorial is just 1. So we end up with the same answer. And you might notice what we actually have. We have 11 objects, 4 of which are I's, 2 of which are P's, 1 of which is an M, and 4 of which are S's. So it looks like we can come up with a general formula of taking the total number of objects, factorial, divided by each of the individual types of objects that you have, factorial. So let's go generalize this now.